Welcome, ladies and gentlemen. So what I'd like to do is show you how to solve multi-step equations now when we have a variable on both sides. So just like how we did solving equations when we had a variable on the same side, now we are going to have variables on opposite sides. So there's a couple of extra steps. Now, again, the main important thing is we need to identify the variable that we're going to solve for, the variable that we're going to isolate. Now, these are one variable equations, meaning even though we might have multiple forms of the variable, there is exactly only that one. You know, we're only dealing with w's here, z's here, y's here, x's there, and so forth. So the main important thing is when we're going to solve for a variable, we need to get that one variable on one side and get it all by itself. Well, we have variables on both sides, so we need to get them on the same side. But before we do that, we need to simplify it down so that it is, I don't know, simplify it down. I don't know what I'm thinking of. I'm trying to maybe think of a good word. But simplify it down, so therefore basically maybe there's no more parentheses and it's simplified as much as possible. I think it's a little bit easier when I get through it. So let's go ahead and get started. So in this case, what I'm trying to say is I cannot isolate the variable because this variable right now is being multiplied by 9. So what I need to do is apply the distributive property to simplify the variable. So I'm going to multiply 9 by z minus 3. By applying the distributive property, I get 9z. 9 times z is 9z. 9 times negative 3 is a negative 27 equals 12z. Now I cannot simplify the equations any further, right? That's what I was trying to get to. So you simplify it where I cannot simplify the left side nor the right side. So you want to simplify down so you can't simplify the left or right side anymore. Good, that's what I meant to say. All right, now what we need to do is we need to pick a side. Either solve on the left side, either solve on the right side. You should be kind of trained, and you'll see a lot more. Most of the problems you would do is you always solve the variable on the left side. Now, that's all fine and good. However, I always like to, rather than just always saying I'm always going to solve for the variable on the left side, I always like to solve for the variable where it's going to be positive. And what I mean by that is if I was going to solve for the variable on the left side, that means I'd have to get rid of 12z on the right side. So I'd have to subtract a 12z on both sides. Well, if I subtract a 12z on both sides, 9z minus 12z is going to be a negative 3z. There's nothing wrong with that, but then I'm just going to have to divide by a negative number at the end, which I just really don't like doing. So my mode of thinking when I'm doing these problems is I always like to solve where the variable is going to be positive at the positive. So what I see here is I'm going to get, instead of getting the variables on the left side, I'm going to leave the variable on the right side. So therefore, I need to get rid of 9z. So to do that, I'm going to subtract a 9z on both sides. By doing that, I now have a negative 27 equals positive 3z. Therefore, now all I need to do to solve for my variable, I need to undo multiplying by 3, which would be divide by 3. And therefore, negative 27 divided by 3 is going to be a negative 9 equals z. And if you would have done it the other way, you just would have been dividing by a negative 3, which is not a big deal. I always just like to solve to make sure my variable is positive and not have to divide by a negative. But it's a small point. It really doesn't matter. All right. In the next example, I actually have both sides are already simplified, right? There's no other operation. There's no parentheses I need to apply first. So now I can immediately get to my next step, which is just getting the variable on the same side. In this case, I see that if I subtract a 6y on both sides, I'll have a positive y on the left side. So that's exactly what I'm going to do. I'm going to subtract a 6y on both sides. 7y minus 6y is just going to be y plus 5 equals, that goes to 0, equals 11. Now, to solve for y, I just need to undo adding 5. So I'm going to subtract a 5 on both sides. And I'm left with y equals a positive 6. All right, in the next example here, you can see now I have multiple parentheses. So when you have multiple parentheses, basically what you're going to want to do is, again, simplify them so that both the left side and the right side of the equation are simplified as far as you can go. So to do that, I'm going to apply distributive property on the left side and distributive property on the right side. When doing that, I now obtain 3x plus 3 equals 2x plus 22. Now I need to get the variable to the same side. And you can see it's be easiest for me to get the variable on the left side. So to do that, I'm going to subtract a 2x on both sides. That's just going to leave me with an x plus 3 equals 22. Now, to solve for x, I'm going to subtract a 3 on both sides. And my final answer is x equals 19. All right. In the last example here, you can see that I have multiple variables on the left side. So again, the main important thing is to simplify this, right? So just like when we were solving multi-step equations when you had the variable on the same side, the first thing we're going to want to do here is simplify this left side of the equation. So by doing that, I can simply, since these are on the same side of the equation, I can just combine them as is. I am going to do a little bit extra work and show you that you can just rewrite the equation. So you don't need to use the properties of equality. When you have the variable or numbers on the same side, you can just combine them. You don't need to use properties of equality. So 5w minus 12w is going to be a negative 7w plus 8 equals 16 minus 15w. Now, again, what we want to do is get our variable to the same side. That's the first thing I want to do. Now, you can see I both have two negative coefficients for my variable. So now, instead of using the inverse operation of subtraction like I did for all these, I'm going to have to add. So what I see is if I add a 15w on both sides, that's going to make the w positive on the left side. So I'm going to get rid of the negative 15w on the right side by adding a positive 15w on both sides. That now goes to 0w, which is just 0. And this becomes a positive 8w plus 8 equals 16. Now, to solve, now it's a two-step equation. So I solve by subtracting 8 on both sides. And I get 8w equals positive 8. Then I divide by 8 on both sides. And I get w equals 1. All right, for the next example here, again, you might say, oh, well, it looks very similar to this other one, right? And yeah, you're just going to follow, again, the same process. We're going to apply distributive property here. And when doing that, I obtain 3x minus 9 equals 5 plus 3x. So now we kind of look at a problem, though, because we have 3x on the same side. Well, if I'm going to get rid of one, they're exactly the same now. Now they're not different like they were before. So when they're exactly the same, you just need to pick, well, all right, let's get rid of the 3x on the left side. So if I subtract the 3x on both sides, though, that eliminates the 3x on both sides, and I'm left with a negative 9 equals 5. Well, negative 5 does not equal 9, right? Negative 9 only equals negative 9. It does not equal 5. So therefore, those sides are not true. Therefore, this is no solution. Meaning there is not a value for x in the real number system that is going to make this equation true. So we'll just write no solution. In the next example here, again, we need to simplify it. I'm not going to rewrite these like I did over there. You see that I have variables on the same side and numbers on the same side. So I am just going to, just variables on the same side. So I'm just going to combine them. 7y minus 2y is 5y plus 4 equals, or 3 plus 1, I can just combine them, equals 5y plus 4. Now, again, just like we did over here, I'm going to have to get rid of the 5y. So I'll subtract 5y on both sides. And what I'm left with is 4 equals 4. So in this case, they weren't equal to each other, so there's no solution. Here, 4 equals 4. That means no matter what value you pick for y in this equation, the left side is always going to be equal to the right side. So when we have something like that, we write infinite many solutions. So there you go, ladies and gentlemen. That is how you solve a multi-step equation when you have a variable on the same side. Thanks.